Hello. Can you hear me? Well, yeah, thanks. Cool. Yeah. So, I work at Shopify, and for those of you that might not know, Shopify is the leading commerce platform around the world, and we serve millions of merchants. So today I want to talk about context engineering, that is defined as the art of feeding LLMs, and I want to talk to you about it from my experience on building really AI assistants that live in production and work at the scale of millions of users. Today I'm going to talk about Sidekick, which is the assistant that I'm currently working on. So yeah, a little bit about Sidekick and about Shopify. So this is the admin page for Setting North. Setting North is a real business that sells authentic Canadian maple syrup. And this is basically the homepage for Shopify, where merchants can basically operate their business. They can see their main business metrics and KPIs, but also on the left side, they have all the tools they need in order to manage inventory, fulfill orders, manage markets, different sales channels, so on and so forth. So Sidekick is basically operates here in this surface on the left side of the screen, and they can open it by clicking in this icon at the top. And right now, this is the main surface, and it's like a chatbot interface, but we also have multimodal where people can just call Sidekick and do a screen sharing and basically help them operate their business. So you can see at the bottom that Sidekick already, when you open it, already provides some suggestions on what the merchant can do. And this is basically super personalized based on the context that we are feeding about the merchant at the right time. Fun fact, this story is actually from Andrew, which is our director of engineering. So you can see that we are constantly dog feeding this product with real merchants. And it operates at the scale of millions. So we have millions of users that use this product. So now let's take a look at one example of what Sidekick can do. Let's say Andrew wants to get rid of a lot of stock that has in his warehouse. So he's busy doing a bunch of things, and he just wants to ask Sidekick to create a discount for the worst performing product. In theory, without Sidekick, he will need to find all these worst performing products. But instead, he can just tell, hey, Sidekick, please create a discount for my worst performing products. And then Sidekick will start his agentic loop and plan the task that he needs to do and figure it out. So in this case, Sidekick decomposed the task into two main actions to do. The first action is to call the analytics tool to find the worst performing products. And you see here in the right side that it lists the worst performing products by sales in the last 30 days. And the next step is to call the form filling tool that will take those products and fetch the schema of the discount form and will generate all the values for that schema. Once this is done, the user can click here in preview, and automatically we will fill the form in the Shopify admin. Then the user can see, correctly, Sidekick has completely correctly added the products that I want to create the discount for, and then has assigned a 25% discount for these products. But the user might think, I want to be more aggressive. I want to set 50% discount or wherever. So they can either manually update here the field, or they can ask Sidekick in a follow-up to iterate on this. And we don't do mutations, so the agent doesn't do mutations directly, but it needs to be supervised at this moment, so the user should have to save the actual discount. So you might be asking how we are doing this. This is the current architecture, and we are basically running an agentic loop. So whenever there is a new user request, we kick this agentic loop by having Sidekick loading the right prompts, the right tools based on the configuration of the user, and then it will decide whether it needs to interact with the world here, internal Shopify tools, or it can actually directly answer the user. If Sidekick decides that it needs to do some tools, it will make the tool calls, and the tools will send back a tool message that will help the main Sidekick LLM continue the agentic loop. This is pretty standard, but let's get into some of these tools that we have right now. By the way, right now we are having around 20 or more tools, but this is continuously growing, and this is going to become a bottleneck that maybe we can discuss later about this. But yes, these are some of the tools. One of the most important ones that we are seeing are analytics, so help merchants understand like their operating picture of their business. Like for instance, how much did they sell in the last 30 days? But we can do more complex stuff like complex funnel analysis, and also customer segmentations. Like if the user wants to like basically target the specific segments, he can ask Sidekick to create those list of customers to send emails or wherever. The actual common thing that they have, both these two tools, is that internally there is another specialized LLM that we train, and that generates this bespoke query language that is internal to Shopify, and then we run that against the actual database, and we send back the data to the main LLM to report to the user. Other skills include navigation. So like if they want to go to other pages, we can automatically do that. And other skills like help, which is just drag over the help center docs, and form filling, which is the one I was discussing before, where we just fetch the schema of the form that we want to fill, and yeah, it will just do it. It's also RAG. So now let's get into the topic of context engineering. So first, like let's address the elephant in the room. So we've seen like reports of, okay, DAG is red. I don't think many people here believe that, but in theory, like we are getting more and more LLMs with large support for larger context window, like Gemini supports 1 million tokens, so on. This is going to grow, but in practical terms, if you add more and more tokens into the context window, like distraction following capabilities go down significantly. And this is like known as the needle in the haystack problem. Even benchmarks say otherwise. It goes down. The more tools you have, the more noisy, or the more likelihood you have that you will have noisy instructions or conflicting instructions. Also, like real applications, they don't fit in 1 million context window, or many of them, they don't fit, so it's not really a scalable solution. As you add more tokens, also cost goes up and latency goes up. And for us, latency is really important. We want to provide like a good experience, so it's something that we really take a look at those metrics. So I want to go through several use cases of different context engineering tactics that we are using. The first one is about managing context window. So like whenever you build an agent, you might think that, okay, I'm just going to add like the main instructions for the agent. I'm going to explain how I want to behave in general. I will define the tools. I will add a bunch of examples on how to use those tools. I will share some information about the user, and then the user will come ask for for a task to be completed. We will run the agentic loop, and it will be done, and we will be happy. The reality that we've seen is that there is way more messy, because the user might ask a request, and you will start triggering the agentic loop with multiple tools. But then, like in the example at the beginning, I might have set up or Sidekick might have set up the discount percentage to 25%, but the user might want, oh no, I actually want 50%, please do it for me. And these small tweaks, like they keep adding tokens into the context window. And we've seen at Shopify that, for instance, when I code in Cursor, if I want to do another task, I will just open a new conversation. But not every user is like us, like they understand like what's going on. They will continue. Some users, they will just continue having like completely different new conversations into the same chat, thinking that we are going to do as well. And so this is one of the problematics that we see in production. So how we can address some of these. So basically, I didn't say it before, but for some statistics about token usage in our scenario is that for each token in our user message, we have 10x more tokens in the system message, and we have 100x more tokens in the tool messages. So tool messages really take a lot of space in the context window, and basically the more naive thing to do is just get rid of the token or of the tool messages once they have been processed by the LLM, because they are pretty much useless. Once the LLM has internalized what's the important context that was in that tool message. that's the first thing. And the other thing is that, as I said before, like if you are in turn 50, like what happened in the first turn is pretty much useless, or yeah, is not really relevant for the current turn. So keeping those turns in memory just makes everything like slow, expensive, and yeah, the likelihood of things going out of rails is way higher. But of course, like if you start removing stuff from the context, you might create like a weird experience where the user said something to you, and he thinks you have it in context, but you don't have it in context anymore. So that could be like problematic user experience. So how we are addressing some of this is that, yeah, we also have integrated memory into Sidekick. And how we are thinking about this memory problem is that we have, for us, it's a system that has three main components. It has user preferences. We also build a user profile, and then we also have episodic memory. So I'm going to go through all of them. So in terms of user preferences, we call them explicit memory. And imagine this scenario where the user says, whenever you generate a new product image for me, please use this following background because it aligns with my with the vision I want to tell my customers about products. So in this case, for instance, we say an Ontario lake on an autumn with a float plane taking off behind the product as my preferred background for images. So what's going on here is that we call it explicit because we are actually telling the user, hey, we are saving this about you, and we want you to be aware that this is going to be used in future chats. How this works in practice is that we have a couple of tools that the agent can call, one for create or update preferences or memories, and one to delete them. One thing that we wanted to do here is like, unlike coding agents where you have like cursor rules or you have like markdown files like agents.md, here we don't want to allow users to type their own preferences because, as I said, it's not the same users as we are with coding tools. So we want the LLM to generate those preferences because the LLM will be better at bet and provide basically not safe, unsafe preferences. So once we have those preferences saved to the database, whenever there is a new turn, we will inject that into the system context, and it will be able to generate. Like for instance, here, like I say, create an image of a product based on maple syrup, 200 milliliters, and although like the original image does not contain this background, it automatically creates the background based on the preferences. The other one is user profile, and we call it implicit memory, because what's going on here is that the user interacts with Sidekick and with Shopify overall, and we are automatically building up a user profile of what they are doing in the background and what's important for them. One key thing about user profile is that we are not opinionated on the type of structure that we want the LLM to generate. So we kind of have some guidelines, but it's pretty much free text because different users do different stuff. So we want to allow the LLM to make a decision on how to generate this user profile. How this works is that on an idle job, we will take past conversations and also other events that happen in the admin. We'll run them through some LLM system, and this LLM system will synthesize like the past activities and get interest, get like long-term goals, so on and so forth. And then the same as with user preferences, in the next conversation or in the next turn, they will be injected into the system message. So the third type of memory system is episodic memory. And yeah, the problem with the previous type of memories that I described before is that both user profile and user preferences, they are great to personalize kind of like the overall experience, but they cannot go into the detail of what happened in the past, right? So for instance, let's think about this case where Sidekick has helped create like a very complex analytics query with some funnels and some conversion analysis. And the user leaves, comes back tomorrow and wants to rerun the same analysis. So the user can just ask, can you run the latest analytics query that you run for me? And basically what we are doing is RAG over the past conversations or the past interactions. And based on that, we are generating the response. This is a search system, and unlike other discussions that have been going on in this conference, we tried all these graph RAG approaches, graph databases. For us in production, I think it wasn't like the best decision because it adds too much complexity for the benefit that they bring in terms of the type of answers that you can get. So this is basically a hybrid search system. So the last topic I want to talk about is just-in-time instructions. So first let's talk about just-in-time tool instructions. So taking the example from the episodic memory, where we do a search for, let's say, 10 chunks from past conversations, we cannot inject that into the LLM. Well, you can, but the results are going to be bad, and the likelihood of hallucinations is bigger. So what we typically do on all these skills is that we basically collocate instructions and data into the same tool message. And there are several reasons that this is like a good idea. The first one is because everything is on the same message, so it's way easier for the LLM to pay attention to instructions and not be and don't have like weird interactions with things that were said in the past. The second one is that we avoid adding them into the system message, like how do you need to use the output of different tools. Like you don't want to put them here because you don't know if you are ever going to call the tool. The third one is that you basically can have better separation of concerns because these instructions can live like in the class where you have the tool. And also, basically you can do conditional instructions because depending on the type of results that you get, you can ask the LLM to do one thing or a different thing. For instance, if it doesn't get any results, you could ask Sidekick to, hey, I haven't gotten any results. Please search for an alternative trajectory to solve the user request. Or if you have errors, you can also say the same thing to try to find an alternative or try to repeat. Or even try to expand the filters for how much time span you are going to search for these interactions. The other one is user safety instructions. So we are also adding just-in-time instructions in the user message. So let's imagine that the user has said, create a new discount for my worst performing products. So we wrap up the user message in that kind of XML, and we add other stuff like user context. In this case, is empty, but it could be like files that we reference during the chat. Like for instance, if I'm reference a different product, then we will put here the GID and safety instructions that we are telling basically Sidekick to please never contradict the original Sidekick instructions or to guidelines. What we've seen internally is that with these safety instructions, we have seen increase 5 to 10% in instruction adherence in some of our internal benchmarks, and also the likelihood of being jailbreak is also lower. So yeah, are some of the tactics that we've used. Like there are many more, but we don't have time to talk about all of them. So yeah, like if you have any questions, I'm happy to take some. And also we are hiring. So if you are interested, you can ping me, and yeah, we can talk about this.